No issues.
Go ahead, go ahead, go ahead.
Is it good? Okay. So, a couple of weeks ago, when I started making this presentation, there were a number of ways I could have taken this presentation. However, I decided to keep it a very high level overview of the topic. And in doing so, I'm going to share with you some valuable insights into this field. And we are going to answer some of the very key questions related to robotics. Generally, when I start my presentation, I always have an agenda as my first slide, but I wanted to keep it a little different this time. I wanted to make you think right off the bat about robotics. So let's start with a few questions. And I would want you to answer these questions. Don't worry, they aren't going to be complex mathematical questions. They're just going to be simple
Only
yes no
777
questions.
is pending. That anyhow, I will start. Yeah.
Yeah, I saw that. Yeah, so he's not rushing, so we can do next.
Yeah,
week.
because
No
then
problem.
that all the pits, right?
Uh,
So that usually
someone,
will take time.
please,
40 minutes to
Yeah,
complete.
yeah, yeah.
Okay, sorry.
Oh, no issues, no issues. So let's make this session a little interactive. So if you think the answer to a question is yes, just go to your emoji and put a thumbs up. If you think the answer is no, put a thumbs down, right? Just to quickly go over how to put up the emojis, you just go down to this bar on the bottom, click this, and then select either a thumbs up or a thumbs down, right? Just to make sure everyone is on the same page, can you like do a favor and put a thumbs up right now? Oh, yeah, I can see a lot of thumbs up. Perfect, perfect, perfect. Okay, thank you. So the first question for today is, do you think your dishwasher is a robot? Thumbs up or a thumbs down? Thumbs up, thumbs up, thumbs up. Okay. I can see 3, 4, 5 thumbs up. Okay. Wow. A lot of people think that their dishwasher is a robot. Wow. So the second question is, do you think robots are intelligent? Again, either a thumbs up or a thumbs down. Thumbs down, thumbs down. Okay. Thumbs up. I can see a mix of opinion here. Okay. That's nice. Okay. Perfect. And the third and the last question is, do you think robots are going to take over our jobs in the next 5 years? That's a interesting one. Okay, thumbs down, thumbs down. Oh, everyone thinks that they aren't going to. Oh, 1% thinks, 2% thinks that they are going to replace us. Wow. It is going to be an interesting session. So for the next 20 or so minutes, we are going to dive into these three questions and also explore a few other areas. And at the end, what I've decided is I will stop like 5 minutes earlier, and then we can have a small Q&A session, just in case if anyone has questions related to the presentation or to any area of robotics in general. So moving forward, when you hear the word robot, what comes to your mind? Usually when I'm talking to someone and I mention the word robot and I ask them what came to their mind, it is normally either a human-like robot, which we call a humanoid robot, or something like this, which is these large manipulator hands, robotic hands working in factories, making cars, doing all sorts of additive manufacturing, painting and stuff. But the thing is that the world of robotics is huge. These are just a few of the different types of robots that are. So I just wanted to quickly take over the different types of robots that they are and their applications. So this one right here is a humanoid robot, which is made to look similar to a human. And the objective is to make it perform tasks that humans can do. This one is a robotic manipulator or a robotic hand. The end of this, which is like the gripper, is called the end effector, and it is used in several factories nowadays. This one is called a hexapod. It looks similar to a spider and it can crawl on different terrains, and it can even climb walls. This one is a four-legged robot, which has been made by MIT. If anyone is interested, you can always search for this robot. It's called MIT Cheetah. And the reason they have called it Cheetah is because they are trying to make it run faster and faster with every iteration. The last time I checked a couple of days ago, they have made it so fast that it can run faster than the fastest human. So it can run in speeds exceeding 30 miles per hour. And now the ultimate aim is to make it run faster than a cheetah. This one is a drone, which I'm sure most of us have seen, like recording videos and stuff. So the drone has already become famous nowadays. This one is a rover which is used for exploring different planets. So it is extensively used by NASA to send to other planets to see if they are habitable or not. This one is a robotic vacuum that I am sure most or many of us have in our houses. This one is a snake robot. So this robot is capable of swimming underwater. It can go underwater at depths of more than 2,000 feet. So it can go underwater at such depths. It can swim and it can like travel from A to B, or it can even record images and videos and show us what the underwater life is. So by using this robot, we are starting to see how the different creatures that live 2,000 feet and below underwater. This one is a robot that is used by Amazon to streamline their logistics. So it is capable of loading heavy packages and boxes and moving them from point A to point B. This right here is a delivery robot. So this is going to become common in a few years, and it is ultimately going to replace the Uber Eats and the DoorDash and all these food apps that we have. So all the restaurant needs to do is the restaurant person needs to open this container or the robot, place the food, close it, and then it is autonomously going to drive to the person's house and drop off the food. This one right here is an agricultural robot which can like sow 8 to 10 different seeds at one time and even water them at the perfect time. And this one right here is a relatively new type of robot which is called soft robots. So these robots are pneumatically controlled and they have flexible bodies. Generally, when we think of robots, we think of robots having these rigid bodies and picking up objects or moving huge objects. But this robot is a little different. It is pneumatically controlled. So by changing the air pressure, you can not only change its shape, but you can make it crawl and move around. One of their main applications is for search and rescue operations. So, in case of an earthquake, these robots can creep into the debris, they can be fitted with a camera, and they can help to find any survivors. So, these were just a few different types of robots. The types of robots are so many that I cannot even put them out here. So now we have seen that robots comes in all shapes and sizes. So it's important to understand what makes a robot, right? So for that, let me go next. Yeah. So we need to understand what the definition of a robot is. So the definition states that a robot is an autonomous machine capable of sensing its environment, carrying out computations to make decisions, and performing actions in the real world. So it's just three things that makes a robot a robot. It is sensing, computing, and performing actions. Now, if we go back to our example, sorry. Yeah, if we go back to our dishwasher example, in the right of this definition, we can see that the dishwasher is in fact a robot. It senses, so it senses the water and the air temperature. It does a bunch of different basic computations. It computes when to add the detergent, when to drain dirty water, and the optimum water level. And then it performs the action, which is it cleans the dishes and sometimes even dries them. So a dishwasher is in fact a robot, one of the very simple kind. And another robot that we normally use in our day-to-day life is the cruise control of our cars. So when we are driving on the interstate, we put on the cruise control and we relax. So what it is doing is it is sensing what your current speed is. It computes and determines how far your current speed is to the speed that you want, and it takes the action. It pumps up the gas to make us go at the desired speed. So now coming to the classification of robots. Robots are generally classified in two main categories. The first being industrial robots and the other being mobile robots, or sometimes often referred to as service robots. In the industrial robots, there are two further subcategories: the stationary robots, which are just these ones, the large robotic hands, and then there are limited movable robots. What this means is the scope of the movement of the robot is limited to a particular area. So let's say, for in the case of the Amazon robot, it can only move within a certain area of the warehouse or just the entire warehouse, and it cannot go outside it and perform. So these are limited industrial robots, and there are mobile robots which have like the classical variation, which have wheels, which can fly, which can go underwater. Then there are the legged variations, which have 2 legs as a human, 4 legs to mimic a cheetah, 6 legs, 8 legs for to become a snake or to become a spider. And then there's this advanced category such as the nano robots, which are very small. Then there are bio-inspired robots, and then there are soft robots. So just to give you an overview of how the robots are classified. Moving forward, now we know that the robots are accurate, right? We know that they are consistent. We have always seen the movies that the robots like do all these tasks and never wear out, they never tire out, and they can even work in extreme environments that are hazardous to humans. But the next question is, do you think they are intelligent? So by intelligence, I mean, can the robot do stuff that they aren't specifically programmed to do? Or another way to put it would be, would they be able to react in changing environments? So before we answer that, let me show you a quick video. I think someone just asked something in the chat. Mr. Nazir, if you can see the chat.
Check.
I think a pop-up appeared on my screen.
Yes, Patty Kumar, is a soft robot the same thing as a bot?
And no, generally, when we say bot, we are referring to robots in general. Soft robot is a very small category of robots that are now starting to like interest a lot of different people, different professors, and the research is growing at a staggering rate. But no, bots are just robots in general, and they do not specifically refer to soft robots. Okay, so now before we answer the question of are robots intelligent, let me show you a quick video. So if I, yeah. So here, this is one of the humanoid robot made by Boston Dynamics. For those who are interested in robots, they would already know Boston Dynamics. It is a very huge name in the world of robots. This is a company that started back in 1990s, and they have been working on robots since. So let us see this animation of the robot, this video. So it moves like a human. It is able to climb different objects, even jump, get down stairs, and walk on these slanted surfaces. And it just looks so like a human, right? And very soon there's going to be another of his brother joining us. So, and he is going to do the entire thing in reverse. And now they are going to do something very interesting. Right about now, they do a backflip. Wow. And they do another one. And now they even do a little celebration just because they have accomplished the entire task. So it is videos like these that make us think that robots are intelligent, they can do all of this on their own. But if you ask me, robots are not intelligent. They can only do what they are specifically programmed to do. So in the video that we just saw, these robots have been specifically programmed to do what they just did. It took months and months of coding to be able to make the robots do what you just saw. It wasn't like they just did not put the robots there and they started moving. It was months and months of coding. So robots, and if we like go back to the definition as well, nowhere in the definition does it say that robots are smart. So we have like put it to a side that robots are not smart. But there is a way of making them smart. That is what we are going to talk about next. So, before we dive into how we are making them smart, we need to understand that artificial intelligence, AI, and robotics have existed for a very long time. Both of them are pretty old fields. So, artificial intelligence is just like if you search on Google, it is how your results pop up, or how Netflix does its recommendation system, or how when you are on Amazon, it shows you all these related products. So that is artificial intelligence, and robots are all these different creatures moving about. So the the both areas, AI and robotics have been there for a long time. It is now that what we are doing is we are making them overlap each other, and the area where they overlap, that is known as the artificially intelligent robots. And what we are trying to accomplish is we are trying to bring artificial intelligence into robots and make them smart. And slowly and gradually, what we want is we want to have this entire robotics circuit inside of AI. So we would ideally want all the robots to be artificially intelligent. But right now, it's just this small chunk. So, okay, we can make them smart by integrating AI into them. But how do we do that? So, and why are we making them smart in the first place, right? If robots have existed for so long, they are capable of doing so much. Why is there a need to make them smart in the first place? Why go the extra mile, right? So I have a very interesting example to demonstrate why we are making them smart. So in the year 2011, what NASA did was they sent a rover to Mars, which was called Curiosity. It was sent to Mars, and the objective was to determine if Mars was habitable for humans or not. What they were doing is they were communicating with the robot via radio waves, and since there is vacuum, so the radio waves travel at the speed of light, which is like 300,000 kilometer per hour, which is very fast. But the distance is so huge that even at the speed of light, it would take the signal is 12 whole minutes to go from Earth to Mars, and another 12 to be received back from Mars to Earth. So you see, there was a communication delay. And what we wanted the robot to do was we wanted it to capture images of different rocks on Mars. So what used to happen was there was this engineer who used to sit in the NASA headquarters. He used to navigate the robot and tell the robot to take a picture of a rock. The robot used to take a picture. It used to send the picture back, and it used to take around half an hour to 1 hour for just one picture to be received. And most of the time, the pictures weren't that good. And practically we wanted thousands and thousands of photos, so it wasn't even feasible for a human to control and make the robot take all those pictures. So what we did was we in 2016 we incorporated AI into the Mars rover Curiosity. The way that we did incorporate AI into it was very nice. So what we did was we showed the robot a few pictures of the types of rocks that we wanted. So we just showed it a few pictures, and then we gave it a free hand to take as many pictures as it wanted of whatever it wanted. So what it started doing was it started taking thousands and thousands of pictures and send them our way. Then there was this person who used to browse through the pictures and see if there were any picture of the rocks that we wanted. 99% of the pictures were the garbage, but there were a few that were good of the rocks that we wanted. So the person looking at the pictures used to assign a positive rating to the pictures that were of our importance, which were of rocks, and negative rating to all the other pictures. So by doing this, he was reinforcing the robot. He was telling the robot that you are getting a positive rating for the good pictures, negative for the bad pictures. And this methodology in the world of AI is known as reinforcement learning. And slowly and gradually, the robot becomes smart enough that the robot realized that he had to converge towards a positive solution rather than a negative solution. And a few thousand pictures down the line, the robot was able to know exactly what we wanted, and there was no need to control the robot. The robot became autonomous. It used to go navigate the terrain, take pictures, send them to us, and over like 6-7 years that it was in operation, it sent us thousands and thousands of pictures, which we use. So that was one of the reasons why we are making them smart. to help us to do a lot of different tasks. That kind of brings me to almost the end of my presentation, except I just wanted to cover this very interesting topic, which is, are we going to be replaced by robots soon? Uh, there was this study done by PricewaterhouseCoopers and about robotics, and I've just picked this graph from their study. So at the bottom we can see that there are three legends. So there is this algorithm wave, augmentation wave, and autonomy wave. These are just three different time frames that they are referring to. So the algorithm wave is the year 2020 to 2025, and the augmentation and autonomy wave take it all the way to 2040. And what this bar chart shows us is the jobs that are at risk of high automation. Something that of importance to note from this bar chart is the education level. So we can see that right now and in the next 3 years, the number of jobs that are at risk of automation is very few. However, within the next 15 years, that is going to jump greatly. And the jobs that require low or medium scale level education level are going to be replaced by robots sooner than later. However, the jobs which require a graduate degree are going to be remain relatively safer. And then they got this another two graphs. So this one shows the industry-wise breakage of the different jobs at the risk of automation. And not surprisingly, the industries that rely more on repetitive tasks are going to have a greater risk of automation by robots, and a lot of jobs are going to be taken by robots, while industries such as healthcare and education, which rely on very unique problem solving, are going to be very less affected by robots. And this bar chart just shows us the different positions that are going to be affected. So operators are going to be replaced the soonest probably, and the people who are going to be safer would be the top level management, the decision makers in an organization. So just by looking at these bar chart, it kind of makes one nervous. It gives a picture that probably robots are going to replace humans soon, and maybe 10 years down the line, humans would become redundant. We would just be sitting and enjoying while robots would do all the work. However, if one goes into the detail of this report and analyzes it, so it gives a completely different picture. I've just put a part section of a conclusion here, which states that AI and robotics will be disruptive for labor markets, and some jobs will be replaced or fundamentally change in nature. But many new jobs will be created, and the long-term effect would be positive. So the takeaway is that even though when robots come, a lot of jobs are going to be replaced, they are going to be changed, but as a result of introduction of robots, a lot of new jobs are going to be created. People are going to start educating themselves more. There are going to be new jobs, new ways of thinking about things, and the job market overall is going to remain at least the same, if not increase, for humans. So that kind of brings me to the end. If anyone would want to connect with me, you can always find all my information on my website here. And if anyone is interested to learn more about robotics, you can always check out my channel on YouTube. And now, if anyone has any questions, just shoot away.
Zane, this is great. Thanks. Actually, you preempted my questions. You were answering my questions as my mind was thinking about these things, and artificial intelligence was one of my questions, and you already answered it. So that's the next wave where we merge AI and robotics. The thoughts I was having during your call was, or during your presentation was, the opportunities for CISCO. Where's our next opportunities? AI for sure, and robotics and operator level, and the factory side of things. That's the next thing. We automate our tests end to end, but we still have the operators in the loop, and that's where we usually run into a lot of issues. We have operator errors, etc. But robotics seems to be the natural fit. Next step. I guess the challenge becomes in: do we have skill sets here at CISCO that can code the AI part and then the mechanical portion of it? So it's almost like a marriage that needs to come together somehow.
Exactly. Yeah.
Great. Thanks, Dane. Appreciate it.
Thank you so much. Yeah. Thank you.
Good. And Zen, many years ago, I was detected with cancer. So I was given two options. One was the traditional method, the radiation surgery and all that. And the other one was the robotic surgery. But at that time, 8-9 years ago, I was kind of like, what is robotic surgery? I was
Yeah.
very skeptical. But now, if I'm given the opportunity, I hope I don't have to go through that again. But if I were to if I were given that opportunity again, I would choose the robotic option rather than the traditional.
Definitely. Yeah, definitely. Anyone would choose a robot over a human for these precise tasks.
Yeah, yeah. And what are the research projects that you are working on now at your university, or you're not allowed to share that?
I can share the basics of it. So I am working with these multiple collaborative robots. So like 10, 15 robots working together to do a single job. And right now, collaborative robots have been there for years and years. But what the new thing about my research is that normally when we talk about collaborative robots, all of these have sensors equipped on them. So every robot in a space knows the location of all the different robots there are. But as we try to ramp the number of robots, if we let's say that there are 100 robots, then every robot knowing the location of every other robot becomes too computationally inefficient and expensive. So what I'm trying to do is I'm trying to come up with a decentralized way of making the robots jump, so the robots won't know the location of all the other robots, but there would be a central server or a computer which would take care of all these computations. It would be sitting on one side doing all these computations. And then so the basic advantage is it is going to increase the speed, and it is going to make make the collaborative robots more effective, and perhaps bring the cost down to a certain level that we can see them working for us rather than just seeing them working in a few YouTube videos.
Got it. Okay. Thank you.
Yeah.
Anybody else? Last question before we conclude this. Any other questions? Okay.
I just want to say, Zain, as a fellow UD alum, I'm very happy to see and watch your presentation. Very, very interesting.
Okay. Thank you so much. Thank you so much.
Yeah.
Thank
Thanks
you.
again. Thanks again, Zen, for a great presentation on robotics. We have been waiting for that. So our next open mic will be announced, will be on SASE, Secure Access, Secure Edge, that Cisco is investing heavily on it. And the speaker will be Poonam Nagpal, and I will announce the date. So look out for the invite and the recording from today's session, along with the slide deck. Thanks all, and have a great weekend.
Thank you, Nazir, for putting this together.
Thank you, sir. Okay. Bye.